All right, let me tell you where I'm going with this, and we'll go from there. I'm basically showing that BPA is, let me get this right for you guys, is that they're the inspecting engineer to CEA, BPA, Bolton, Perez and Associates. I think I referred to it as something else in the BPA in maybe 2 videos back, but that's what BPA stands for now. Also, I'm going to show that they soft-stepped this entire project, and that could, of course, cause some major issues. Let's jump right into the images. Look at this is a coating, and the coating is applied up to this point. It makes you wonder what was here that before the coating, what stopped the coating. Why did it just stop there? Okay, so I'm going to jump around real fast with this because I did this video already, and now I'm not going to edit this one. About the coating. The coating is helpful to tell you what's going on. Okay, because if the coating was applied, if in reference to the cracks, so this is crack analysis. So if the coating was applied after a crack was made, the coating would be inside the cracks. As you can see, the cracks do not have coating inside. That means that this coating was applied and then the cracks appeared after the coating. This gives you a timeline on the cracks, and the inspecting engineer here documented otherwise. He documented that these cracks appeared after the forms were stripped, and this coating is not on the after the forms are stripped. As you would see here, this is what would form when a structure is stripped. It looks like this concrete that went into it initially, and the concrete, unless it was dyed this color, then you're going to get this color. And there's your concrete, and there's your craftsmanship, and all this all he's soft stepping is what I'm saying around products like this, around these cracks, around these craftsmanship details. Just moving around, I guess calling it nothing in his mind, perhaps. I did another video where I said that the reinforcement in line with the post-tensioning can create a buckling effect inside the post-tensioning member itself. A buckling effect with the reinforcement can mirror through. I'd lean towards that in this issue. Now, let's jumping onto this. We have 6 photographs. We're supposed to have a total of 7. So FIU is holding back on that. Moving over to this image here. Moving over to this. This is about phase 1 of the deck. Again, this is Bolton Perez. They're the inspecting engineer, and they mentioned the dry run on September 27th. Verify has approved. Okay, right here. Any slab thickness throughout phase 1 of the deck, right? Phase Verify MCM has achieved proper cover. The dry run on the bridge deck of span 1. Verified MCM has achieved proper cover and slab thickness throughout the phase 1 of the deck. I don't know how a dry run would determine that. Any minor changes were addressed at the time of the inspection. Any minor changes. This minor, he also used another time. This same engineer used the word small. Changes are not minor. Things aren't small. Regardless of the poor cancellation. Okay. Regards. Let's moving on. Okay. Now we come here to. This is the CEI speaking on. February 6th. I'm going to show you a different date. February 28th is when he finally writes about the issues in this inspection. After post-tension bars tendons number 2 and 11, we know about with stress. Cracks were found at moment of the inspection. What? These have been identified per truss member, and a consecutive number within the member. The intent is to monitor these cracks after the bridge is fully tensioned and the main span is at the final location. So there's an issue with cracks, and they're saying the intent is to monitor it after it's in the final location, which would of course be more dangerous because these cracks are unresolved, and they're just going to monitor it after it's in a structural position where it can kill people. Let's be blunt about it. The members showing these small cracks, here's using the word small now, are truss members that share the same blister at the canopy of the already stressed members number 2, stressed on January 30th, and number 11, stressed on January 29th. These dates are interesting, and you can extrapolate however this timeline came about. Number 11 was stressed on the 29th. It appears that it took an entire day to stress this one, and they followed up the following day. And I'm saying the day, I hope they didn't show up late, and it could be an explanation. And then it was finished, the other number 2 was finished on the 30th. As we know, on the day of the collapse, that they finished number 2 all off in one shot, and they were they were at members number 11, already finished the upper, or the higher, if you will, that they finished this one. They finished these 2, and they moved on to these 2. Now, in one day, they've already, before the morning's even finished, if you will, they're already finishing off their entire structure. So why did it take 2 days here to complete the task? 2 days in timeline here. We believe the first now this is the part that's amazing. When he says we're referring to Bolton, the structural engineer, the inspecting engineer for this project. Okay, and this is what we believe, meaning his company, the engineering firm. We believe this first stressing operation has temporarily created tension on members number 3 and number 10. Okay, so when they were stressing these 2, the cracks appeared. And so he believes that it happened as they were on the 29th and the 30th. So remember I said about the painting. So that means this painting would have to happen after the forms are stripped, the concrete cured to some point, and then they applied the coating. So now how all of a sudden do we get that he said that they did an inspection? You'll see it. They did the inspection right after the forms are stripped. I'm confused here because the cracks appeared as they state after, let's go backwards in time here, after the forms are stripped. Actually, we'll go forward. We believe the first stressing operation has temporarily created tension on the members 3 and 10, thus creating cross-section cracks, transferring the tension loads to the steel on these members. Now, transferring the tension loads to the steel on these members. So this is what I said in one of my other videos on my other channel, how the reinforcement can cause a buckle. And he's saying creating a tension. And this would be a bowing effect causing the crack on that in that concrete itself. No other truss members with span 1 show any cracks similar to those shown on numbers 3 and 10. All right, so I blew over that, right? Let's back that up. No other truss members within span 1. Entire span member. None of these other truss in the background here. None of these other truss have an issue. Wait a minute. Similar, he says, to those shown on members 3 and 10. Similar? So, well, similar would mean that it would be the same crack pattern. I mean, similar is so vague. It could look almost identical, but I can say, well, it's not similar because it's off a little bit. That last bit, I consider that different. This is not this is, in my opinion, this is helping someone out in a report. This is soft stepping. All right, this is identifying that there are other cracks, making a document of it, and then downplaying it and this little quick wording here. The intent of the report is to inform design build team of these cracks. It is the design build team responsibility to assess them and determine if these cracks were expected while tensioning and monitoring them accordingly if deemed necessary. Okay, again, if it is the design build's responsibility to assess them. too late. He's already assessed them. Because up here he says, we believe the first stressing operation has temporarily created tension on members 3 and 10, thus creating cross-sectional cracks transferring. It's already been assessed by him. Now, this person, this engineer for CEI, they can use a crack classification card. Crack classification card. And clearly he knows how to line it up. And simply you line it up with how it matches, and you photograph it like this, and you say that's a 0.004. And I'm going to show you he has a problem with, now he has a problem. He can't keep track of how to use a card. I'm going to show you on here how this lines up, and then I'm going to bounce back to that. So I used these measurements off of here. For example, truss number 3 is 70 inches from the bottom of the member extending around the cross section. Extending around the cross section. So this doesn't appear that it's extending around the entire upright, if you will. Let's see, he calls it a truss member. Okay, it doesn't appear to go all the way around the truss member based on his wording. Crack type A, and there are the measurements. Now let's scroll up. Under the same, now it's number 3 is 77 inches also, and here's the crack at 77 inches. Here's the crack at 70 inches. So you now understand what this means when I show you this. So let's make sure I've got the current. Yeah. All right. So here it is this is number 3, and that's 7 inches apart. If you do 70 and 77 inches, and then you would wrap this around. The photograph is terrible because he's only documenting one side of it, not all the other sides. He's not documenting with his crack scale. So let's talk about that real quickly. If this goes around this side, this side, and then back around the other side, you could probably think that the tension on this side created this, the load on this side created tension on this side, causing an opening, a tension crack that wrapped. All right, that's just a thought. It didn't wrap all the way around. Interesting. At least he's not stating that, and we have no photographs. And at least photograph number 7 is not present. All right. Then we have the next. We move down here, and he measures from the base up is what he basically implies. When we move on, here's the rest of the data. We have 150 and 168 inches. 150, 168. That's a rough estimate as per my notes down here. Make it clear to you that this is to scale this, but not my marks. And I know this to be 15 feet, 11 and a half inches from the top of this canopy to right about below the deck, right about there. The canopy's 1 foot thick. So that leaves us about 14 and a half feet. And, I've just got to calculate it. Of course, I can scale it if I want to, but you guys can spend that energy. All right, so this puts this at 18 inches apart, the 168 and 150. These two, and this is member number 10. Then we go to number 10 still, and we've got 119 and 126. Oddly, that's 7 inches apart also. So this makes you go to the rebar reinforcement and wonder, all right, can we get data on the rebar reinforcement? Was it exactly spaced at this part, at this gapping 7 inches? You can clearly take this column and see if you can find this now. The column does exist. You could also find it in as-builts, possibly, if they did the rebar as-built. You can find it in the photographs, tape measure. You can do it. You can determine if this is the rebar that's in there. With that said, he should have suggested and made sure that was more than a suggestion, that this be tested immediately for gamma testing, exploration, or determine exactly why these cracks are appearing. Not the ambiguous, was this predicted? I would hope that no cracks were predicted under tensioning, of the concrete. Okay, here we go here. Photo number 7 is not disclosed by FIU, but they clearly fall under the allowable dates. Why is FIU holding back on this photo number 7? If all of these fell under the same email that was available, photo number 7 is held back for a significant reason. Now, coming back to his chart and this inspecting engineer, watch this. Classification crack type A, less than 0.007 of an inch. Going back to your scale, 0.007 is between a 6 and an 8, right here. Now watch this, 0.04 correction, 0.04. Okay, 0.04 would be down here somewhere. It's a much bigger crack. So what's this engineer doing here? Is this again, the soft stepping and allowing himself, and I'm not being accusational here. I'm just stating a fact. And the fact is this, it's a question. Is he allowing himself an out by doing this, not putting the chart up, and then giving possibly the real crack size here? But this is a conflict. And then here we go with the conflict again. This one's got a range though, but he clearly wrote 0.04/006. So this 0.04 is something else. And then here we are here now. Now, I'm assuming that this is the engineer's report, that this is not a redacted from FIU, although I would okay, moving on from that statement. Again here, 0.007, and then again we're at a 4. Now these cracks obviously look larger than the other ones. This is T10. This is the member, this party member that failed. And would this be a rebar crack? Interesting crack. Interesting crack. Okay. And here we are here. Another interesting crack. The reinforcement would have to look kind of, it's no longer in a straight reinforcement line. If the reinforcement went on an angle, perhaps. But this one's not selling me as a reinforcement. And also we have a lot of unknown cracks, similar cracks, right? Now this one would sell me sort of on reinforcement, this one here. This is back to T3. Now we scroll down, and now we've got a 4 written here, 0.004, but he says less than 0.007. Make up your mind here. What does this 4 mean? I wonder what it means, right? And we scroll in here. We see that this is clearly a larger crack. Let me do one more thing for you about the top crack. If this is in this image, I would hope it is not. Let me go to here. Great. Let's shut that down. And let me get you to, it appears I'm going to grab it somewhere else. Bear with me. I don't want to do editing. Here we go. Because I've had some problems with my software today. Cost me an entire day. Let's look at this crack here. This crack is open. It's not a compressive crack that you would see a compression. This is an open crack, an open jigsaw puzzle now, you see. This one is an oddball. So how can you do it? This is the floor appears. How could you get an open crack? This could move away, or this could move away, the bottom deck. And for this to move away, you would have a tension in the bottom deck, say the center span, just talking, and it would bow downwards, and that would pull away. That could pull this away. That's just an idea, which means the bottom deck is not. The loads or this deck is flexing. It's got a deflection in it in the middle, if you say, or somewhere it's got a deflection. It could have the deflection. Well, we've got this one, so let's bounce on. I want to tell you about the deflection in probably another video. And then we got this one also. It's open. It's the same side. This is number 11, I believe, and it's wrapped around. This is in line with the reinforcement, I think. Sorry for the cough. And again, it's an open crack. And look, it's open, and there's the shadow, the lighting of it. It's open and elevated, if you will. That these are in different positions. That this is just slightly higher than that one. So it's got something going on here. Now let's clarify for you about him stating that he's after the crack. After the crack, and we go to so this is my image here. The difference of these two now. I'm glad I pulled this up for you. notice the different members here. People are wondering why this one did not fail also. These have the post tension in bars towards the center of, and balanced out, if you will, in quarters or thirds, 1, 2, 3, of the post tension bars. And this is a longer member, as reported on the measurements. And these are towards the outside. And I mentioned that, and this is more of a horizontal member, and it's already has an issue where it wants to have just a dead load of it, and the forces want to create a break somewhere in the middle. Just because if you imagine a horizontal, this span like this, the weakest part is in the middle. As it's vertical like this, it's a compressive member. So if they jumped around, they finished this section of the bridge first, and then they came and not jumped around. That was the wrong wording. They moved from there to here, and they did the top one, as we understand that. We're working on the final one, which we know to be the failure one. Literally, the device is still stuck to it, the jacking tool. So if they compress this one, once you compress this one at the top, if you will, at the top of this member, you then create a tension issue, not with the post-tensioning, literally, but a tension issue, because you put a load at the top of this, you now have a tension problem, weakening, if you will, the underside of this member, number 11. And you can counter that with, of course, adding more tension, balancing it, or taking some tension off of that one. But they were adding tension onto this one. Okay, so as the loads add on. So let's back this out and let's look at my notes here. So this is just an odd. Now, it could be like a two-way deal. So this could have been just a racking member to help this whole bridge, keeping it from racking. We don't think it was installed after anything, after any cracks. That would just be, there's no way they did it. It was concrete wrapped around it. This was obviously done in planning to place these at these locations. So now, what's the intent is what you want to know. And as we know, these were going to be detensioned after the main span was complete. The main span cannot be complete until all the longitudinal post-tension cables are complete in this canopy. And it also can't be complete until the upright is in, until the pylons are in, and until the other deck is in. It says not until it's complete. And so this would have to be put under those kips as the drawings show until complete. At the point it was no longer under those kips. Okay, so this is the part where I say it's negligent. If you had it, what was your intent for these? Were these to keep the bridge from racking? Did you think it would rack? What was your prediction? Was it there to, well, I'll go down that road. Was it there to keep together cracks that you knew you would find? And what do you mean? You would keep together cracks of a column? I'm sorry, I refer to this as a column. To keep together this diagonal from what? Falling apart? Well, the moment you have that type of thought, and you have reportedly a couple of loose post-tendon members, post-tension bars, then right then you have a critical problem. To me, that's right then. That's bridge closure time. It's a wild card you're dealing with. It's a panic situation, if you ask me. And that would be because it's a structural. So I don't get how this, with that said, now I don't get why they did not close the bridge, knowing, with that going down that scenario. I can't come up with a scenario where these being loose are an issue. I can only come up with the scenario that it's okay if it was part of the schedule, knowing that when they put it in place, they would go down each one of these and readjust them. And now we do see damage on the top of these nodes. Here, here, and here. We didn't know when that damage took place. When I say damage, that's no typical access. It would be much neater than that. And if it's not much, those are damaged. Those have been jackhammered out before the bridge structure was moved. And we know that because you can find a video showing the bridge structure moving, and then people have told me that, look, it was already had that on each end already had, and you can find them, and it's on the previous videos. You can find that there's already had these have already been accessed. But if you think about it, if you knew you were going to come back and do this, why would you leave such a raggedy, damaged top node? That doesn't make sense. If I knew I had to go there, we would set, some form up there so it'd be nice and neat. It would be professional, and you'd have access again. My thinking is that these were they were supposed to be detentioned, but for some reason they had to go at it again. And they had to go at it with they had to make more access when it was still on the side road, when it's still in there, and they used a jackhammer, and they didn't bother to dress it up because nobody thought that, they figured they'd dress it up later. Nobody would thought that the drone video and all that would now come to haunt them. All right, so we have one more thing to hit, and that would be the engineer statement, which is, where'd you go? So I'm dealing with the 26th. Okay, on 226. Right, so we got the 226. On 228, there we go. That's what I'm looking for. The 228 letter. 228 letter is here. And I'm sorry, guys, for putting you guys through just jumping around like this, but I don't have time to do editing tonight. And I want to share this with you. Okay, so here's the column. Here's the reinforcement that's in line. Here's the video I did of this on my other channel if you guys want to look it up. Oddly, Google has that video trashed. They have me like a reverb repeating statements multiple times. I mean, like one behind another, just perfectly. It's just ridiculous. So here's the post-tensioning where it would have been in there, and I put in this video, I state how this and track, once you're post-tensioning this, could create a tension in this, a deflection, and that deflection could mimic as a crack through the concrete. It weakens it. And that's what the engineer apparently stated in his report. Now I want to get you this. Now photo number 7, it's not showing up. I didn't want to show this yet. This is all tooling, and I got a backside of this tooling for you, but oh, that's perfect. Yeah, that works for us. So if you know that you were going to retension this, why did you trash this? Why did you not just put a nice decorative, I'm going to cough again, a decorative detail in here? Well, I think they jackhammered in here to get access again. This post-tension bar is the one that's the upper one that's not been, it's been already tensioned as we were informed. And now you see it not ejecting out, which is this, one of the claims is when the bridge falls, it pushed the bar out. Well, why didn't it push that one out? It's a thought for you guys. They are in different locations, anchored at different locations. Perhaps this one sheared as this one collapsed and this one did its own thing. Perhaps it did break and eject at some point. Okay, we have the form work up. I'll just keep that there and you guys can evaluate it. And I want to show you, where'd you go? Where'd you go, letter? There we go, letter. Now this is Jose here, the P, professional engineer. PPA, Bolts, this is the company that does the inspection. Now remember, he on the 6th, he went out there and did that inspection on February 6th. And I wrote notes here. Why did this engineer not state that date? He didn't state that in here. Rather, chose to relate the inspection to, quote, after the removal of the formwork. This is himself from sent on February 28th at 3:32 p.m. to MCM, that's the builder, CC. And he CC'd these people. Now, none of these people appear to be FIU in plain language here. Nevertheless, FIU is the one that released this. So FIU, are you in this group somehow? And you didn't respond. And also, you have possession of this. So what is your response to it after you have possession on February 28th? Or when did you get possession? Okay, that's basically down here. All right. If this were true, no coating would be present on structure. Why did they add this in certain areas, hiding something, is what I question. So why did they add that coding in certain areas, as you saw in the with member number 1, how it didn't go all the way up, and you also see it in member number 11 at the bottom. It doesn't go all the way up. All right, and I'll give you a shot of that. But let's come back and he's attached this one. He calls this one subject main span cracks inspection on truss members after formwork / scaffolding removal. So this is implying that the bridge is now freestanding at the ends. After formwork, this is what I'm thinking it's implying. Or is he referring to the scaffolding of the canopy? Okay, so this is a little bit confusing. All right, on truss members after formwork, scaffolding removal. Cracks report after shoring removal PDF. So this would explain some of the coloring, and this also gives us a timeline, and this is where I'm wrapping up the video with you guys. So take note of this. So the scaffolding would have been the canopy, I'm thinking. The truss members would have already been completed. Now you add the formwork, and then you add the coating. Okay, so there's your timeline. That's why I told you I'd get to it all for you guys. Then when you remove the scaffolding, formwork, if you will, now you see why you have that line across, and this is going to be hard. I can't come out of this because it won't let me open the other tab without losing this. I'll go back to that then for you. Okay, please refer to the pictures attached regarding some cracks seen on truss members. So some means not all. There's a lot more. Span 1 after the removal of the formwork. Okay, where's into SC7? Okay, so obviously this allowed to release it. So as I said here, and I'll show you back here now. Let's come back to here, not that. Bear with me. Okay. Bear with me. Okay, so this would have been my thinking. Here are the formwork. The formwork was here after these truss members were put in. Then so you can see how the formwork, how large it was. And this is the cold joint, if you will, of the canopy. And there's the bolt that was set. Okay, so then the formwork's removed. But before the formwork is removed, they went ahead and applied this coating. And so here's the crack, as you can see the continuation. After the formwork is removed, he does an inspection. He mentions the cracks. These appear to be a pass, or this photograph is implying everything. But I mean, it doesn't have any real significance to this engineer. It's just nothing but stress cracks from post-tensioning. It's something else. All right. So now we have a timeline. So let's say this was coded after. Well, it was coded while the forms were still up in the air. So you can figure out when this coating was applied. And I want to show you right here. This is the odd duct. So if this was part of if this is this right here, I believe is the bottom deck. This guy's not standing on his head. Here's a bolt, which is kind of an odd duct. And that's number, all right, I'll just show you what number it is first. That's number 5. Number 5 is down, it's reported down here at number 11. And that's here, but the other side. And this would mean the bolt is here, standing up with a rope on the other, as you look from the other side of this bridge, this structure. So here's this crack. Here's an additional crack. This engineer is it's amazing. So here's this one, the additional crack. I don't think anybody wrote upside down here. I don't think he's standing up on top of his head, and I see a sky here. So this is why I'm saying that this number 5 is reported as number. It's reported over here. As far as I know, it could be on the other end of the bridge. It still doesn't matter. It still shows that application of coating was applied here, even around the bolts, you can see, but stopped right there. And the other, so I'm still leaning this to that it is down, that this is number 11. This is our collapsing, our serious member. And there's the drain, floor drain, I believe. And look at the craftsmanship. Look at this craftsmanship on that deck. Now, the last photo I want to talk about this craftsmanship. It's just amazing. Talking about that craftsmanship, I'm going to end it with something kind of weird. That if you look at the drawings, it states that no, they did not account for a coating to go on top of this bridge. I mean, a layer to go on. Ah, great. A layer to go on the structure, and let me move this over. Bear with me. Yeah, that's it was crashing. Where are you, little duck? There you are. Last image. This is obviously a node that had nothing wrong with it, that was left alone. That's going to be covered by a plate anyway. This is that bar. It's a tension bar. I forget the name of it. Look at this. This is delamination. This means this has a layer installed. This explains why no cold joints are identifiable. Joints here, etc. When that bridge collapsed, that's the concrete below. This is the piece this is the layer that popped off. I've never seen concrete, a solid layer of concrete ever do this. So this is obviously a serious, I don't know, scale it, 1.5 inches, let's call it, of a coating that's on top of this bridge. So here's the real engineering structure here. Ironically, though, when you look at the NTSB's cores, I looked at their core samples, and their core samples do not show this. And they were taking it from the deck, the lower deck, and I don't see them taking core samples above. But this is not on their core samples. I'm ending this video. I'm loading it up, and thanks, guys, for listening. And I'm sorry about that I drug you through, my searching of images, etc. Wish you all the best.